Open your pantry right now and look at what is in there. Not the fresh food, the shelf-stable things, the things that have been there for months, the things you reach for automatically because they have always been there, and your mother had them, and the grocery store always stocks them in the same aisle with the same familiar labels. Most of them have something in them that should not be there. Not in the sense that they will kill you immediately, but in the sense that you eat them multiple times a week, every week, for your entire life. And the thing in them that should not be there accumulates quietly, continuously, in ways that nobody around you was tracking. Japan made different decisions about what goes on the shelf, not because Japanese food culture is inherently cautious, but because Japan's food regulation asks a different question than the American one. The American system tends to ask whether a compound has been proven harmful enough to remove. The Japanese system tends to ask whether a compound is necessary in the first place. If it is not necessary, it does not go in. That difference in the question produces a very different pantry. Here are 13 things in yours right now that Japan stopped eating a long time ago. 1. Bread with azotic carbonamide. The loaf of bread in your pantry has an ingredient list that runs to 15 or 20 items. Bread is 4 ingredients: flour, water, yeast, salt. Everything beyond those 4 is an additive. The specific compound on most American commercial bread labels that is absent from Japanese bread is azotic carbonamide, a dough conditioner also used to manufacture yoga mats and shoe soles. It is approved by the FDA for use in bread. It is banned as a food additive in the European Union, Australia, and Japan. Azotic carbonamide breaks down during baking into semicarbazide and urethane, compounds associated with tumor development in animal studies. The FDA's position is that the concentrations in bread are too low to constitute a risk. Japan's position is that a bread-improving chemical that breaks down into potentially harmful compounds is not necessary in bread, and therefore should not be in bread. Japanese shokupan bread is made with flour, water, yeast, milk, butter, and salt. The softness comes from the tangjong technique, a cooked water roux added to the dough, not from chemical conditioners. It lasts 3 days on the shelf. It does not need to last longer because it is gone. 2. Refined seed oils. The vegetable oil, the crackers made with soybean oil, the salad dressing with canola, the packaged snacks fried in cottonseed oil. Refined seed oils are in almost every processed product in the American pantry, and are consumed in quantities that have no precedent in human dietary history. When heated, refined seed oils oxidize and produce aldehydes, breakdown products that in animal studies at high exposure are associated with DNA damage and cardiovascular effects. The deeper issue is ratio. The human body requires both omega-3 and omega-6 fatty acids in an approximate 1-to-1 ratio. The modern American diet produces a ratio closer to 20-to-1 in favor of omega-6, almost entirely because of the volume of seed oils in processed food. Japanese cooking uses sesame oil, rice, bran oil, and small amounts of neutral oil for specific purposes. Sesame oil is used as a finishing agent, a few drops rather than a cooking medium. Rice bran oil has a high smoke point and a favorable fatty acid profile. Neither is consumed in the quantities that American processed food delivers refined seed oils. The exposure is fundamentally different. 3. High fructose corn syrup. It is in the ketchup, the bread, the salad dressing, the cereal, the granola bar, the crackers, the pasta sauce, the barbecue sauce, the yogurt. High fructose corn syrup appears in an extraordinary range of American pantry staples that have no obvious reason to contain a sweetener at all. High fructose corn syrup is not meaningfully different from sugar in its basic chemistry. It is a mixture of fructose and glucose. The difference is in the delivery. Because it is in so many non-sweet products and in much higher quantities than the sugar that would have been used before it became the default, the average American consumes it at levels that have no historical equivalent. Fructose is metabolized entirely in the liver, at the quantities delivered by a diet. Saturated with high fructose corn syrup, the liver's processing capacity is chronically exceeded, a condition associated with non-alcoholic fatty liver disease, insulin resistance, and metabolic syndrome. Japan uses sugar in food products that require sweetening. It does not use sweeteners in products that do not require them. The exposure is a fraction of the American equivalent. 4. Artificial food dyes. The red cereal, the orange crackers, the bright yellow mustard, the blue sports drink. American processed Food is aggressively colored with synthetic dyes: red 40, yellow 5, yellow 6, blue 1, blue 2, green 3, derived from petroleum and approved by the FDA. Several of these dyes require a warning label in the European Union, a statement that the product may have an adverse effect on activity and attention in children. The warning was required because research demonstrated a link between artificial food dyes and hyperactivity in children. Rather than adding the warning label, most manufacturers reformulated their products for the European market using natural colorings: beet juice, turmeric, paprika extract. The same products sold in America retained the synthetic dyes because no warning was required and reformulation was not mandated. Japan has strict limits on artificial food colorings. Many of the dyes standard in American food products are either prohibited or heavily restricted in Japan. Japanese food gets its color from the food itself or from natural colorings. The idea of adding petroleum-derived dye to make food look more appealing is one that Japanese food regulation has consistently treated with significantly more caution than the American system. 5. BHA and BHT in packaged snacks. The preservatives that keep the chips crispy, the crackers shelf-stable, and the cereal from going rancid. Butylated hydroxyanisole and butylated hydroxytoluene, BHA and BHT, appear on the ingredient lists of a significant proportion of American packaged snack foods and cereals. BHA is listed by the National Toxicology Program as reasonably anticipated to be a human carcinogen based on animal studies showing it causes tumors. BHT has been associated with endocrine disruption in animal studies. Both are approved by the FDA as generally recognized as safe at the concentrations used in food. Japan prohibits BHA in food products. The EU restricts BHT significantly. The compounds are used in American pantry staples at concentrations that individual regulators in other countries have decided are not worth the risk, even if the FDA has not reached the same conclusion. The practical alternative is not complicated. Fats and oils go rancid when exposed to oxygen. Packaging that limits oxygen exposure. Nitrogen-flushed sealed packages, smaller serving sizes that are consumed quickly, achieves the same shelf stability without chemical antioxidants. Japanese snack packaging reflects this. The bags are sealed with minimal air. The serving sizes are smaller. The products move faster because they are consumed faster. Nothing needs to be chemically stabilized against rancidity that does not sit on the shelf long enough to go rancid. 6. Potassium bromate in flour. This one is in the flour itself, rather than a finished product you recognize, which makes it harder to see and easier to consume without knowing. Potassium bromate is added to commercial flour as a dough strengthener and conditioner. It is used by large commercial bakeries and appears in flour sold to restaurants and food manufacturers. It is classified as a possible human carcinogen by the International Agency for Research on Cancer. It is banned in the European Union, Canada, China, and Japan. In the United States, it is permitted by the FDA, which has been encouraging but not requiring bakers to voluntarily phase it out since 1991. When baking is done at sufficiently high temperatures for sufficiently long times, most of the bromate converts to bromide, a less concerning compound. When baking is incomplete or temperatures are lower, residual bromate remains in the finished product. Japanese flour milling uses ascorbic acid, vitamin C, as a dough strengthener, which achieves the same baking result without carcinogen classification or residue concerns. 7. Carrageenan in dairy and non-dairy products. The chocolate milk, the almond milk, the cream cheese, the deli meat, the infant formula. Carrageenan is a thickening and emulsifying agent derived from red seaweed that appears in a significant range of American dairy and dairy alternative products. The controversy around carrageenan centers on a distinction between two forms: undegraded carrageenan, which is food grade, and degraded carrageenan, known as polygeenan, which is a known carcinogen. The concern raised by researchers including Dr. Joanne Tobacman of the University of Illinois is that stomach acid can degrade food-grade carrageenan into polygeenan in the digestive system. Animal studies using food-grade carrageenan have demonstrated intestinal inflammation and colon tumors. Japan uses agar, also derived from seaweed, as a thickening and gelling agent. Agar has been used in Japanese food preparation for centuries, with no associated health concerns. It achieves the same textural results in dairy and gel products without the inflammation association. Carrageenan is not prohibited in Japan, but its use is significantly more limited than in American processed food, and traditional Japanese alternatives are preferred. 8. Brominated vegetable oil in citrus drinks. If you drink Mountain Dew, some citrus sports drinks, or certain fruit-flavored beverages, you have been consuming brominated vegetable oil, BVO, a compound in which vegetable oil has been bonded with bromine to make it dense enough to keep citrus flavoring suspended in the drink rather than floating to the surface. Bromine accumulates in body fat and in the thyroid gland, where it competes with iodine, an essential element for thyroid function. Case studies in medical literature document bromine toxicity from excessive consumption of BVO-containing drinks, with symptoms including headache, memory loss, and skin lesions. The FDA has listed BVO as an interim food additive since 1970, meaning it has been under review for over 50 years without a final determination. Japan prohibits BVO in food and beverages. The EU prohibits it. India prohibits it. In 2023, the FDA finally proposed revoking its authorization for BVO following a study by the National Institutes of Health, over 50 years after the interim classification that was supposed to be temporary. Japanese drinks use natural citrus oils and modified food starches to achieve the same emulsification without bromine accumulation. 9. Propyl gallate in cooking fats. Propyl gallate is an antioxidant preservative used to prevent fats and oils from going rancid. It appears in lard, chicken fat, vegetable shortening, and some dried meat products. It is also found in some chewing gums and cereals. Animal studies have shown that propyl gallate causes tumors in rats. The European Food Safety Authority has expressed concerns about its potential endocrine-disrupting properties. Japan has significantly more restrictive regulations around propyl gallate than the United States, and its use in Japanese food products is limited to specific applications at much lower concentrations than the American standard. The practical reality is the same as BHA and BHT. Propyl gallate is in the product because the fat it is protecting has a longer shelf life than the product would have. Without chemical stabilization, the solution is not a chemical stabilizer. The solution is a product that does not sit on a shelf long enough to require one. 10. Titanium dioxide in sweets and sauces. Titanium dioxide is a white pigment used in paint, sunscreen, and food. In food, it appears as E171 on ingredient labels and is used to make products whiter and brighter. Powdered donuts, white sauces, candies, chewing gum, and certain dairy products. The European Food Safety Authority concluded in 2021 that titanium dioxide can no longer be considered safe as a food additive. The concern is that titanium dioxide nanoparticles accumulate in the body and that genotoxicity, DNA damage, cannot be ruled out. France banned it in food products in 2020. The EU followed in 2022. The UK is reviewing its status. The FDA continues to list titanium dioxide as generally recognized as safe at concentrations up to 1% by weight in food. Japan's use of titanium dioxide in food is permitted but significantly more restricted than the American standard, and the general Japanese preference for food that looks like what it is, rather than food that has been whitened to look more appealing, limits its application considerably. 11. Partially hydrogenated oils. The ones still hiding. Trans fats from partially hydrogenated oils were banned by the FDA in 2018, a decision that is widely cited as one of the most significant food safety victories of the last decade. What is less widely known is that the ban contains an exception. Small quantities of artificial trans fats, less than 0.5 grams per serving, can still be listed as 0 grams trans fat on the nutrition label due to rounding rules. Products that contain partially hydrogenated oils in small quantities per serving can legally claim to contain no trans fats while actually containing them. Shortenings, some crackers, microwave popcorn, and certain packaged baked goods still contain partially hydrogenated oils at levels that round down to 0 on the label. Trans fats raise LDL cholesterol, lower HDL cholesterol, and are associated with cardiovascular disease at any level of consumption. There is no known safe intake level. Japan eliminated partially hydrogenated oils from its food supply ahead of the American ban, and without the rounding exception that allows residual amounts to remain hidden on American labels. 12. Artificial sweeteners in diet products. The diet soda, the sugar-free yogurt, the low-calorie snack bar, the protein powder, artificial sweeteners, aspartame, sucralose, saccharin, azosulfame, potassium are in a wide range of American diet and reduced calorie products, and are consumed daily by a significant proportion of the American population. The WHO classified aspartame as possibly carcinogenic to humans in 2023, Group 2B, based on limited evidence from animal and human studies. The classification is the same category as pickled vegetables and aloe vera extract, meaning the evidence is suggestive but not conclusive. What the WHO's review also found, separately, is that artificial sweeteners do not help with long-term weight management and may be associated with increased risk of type 2 diabetes and cardiovascular disease in high-consuming populations. Japan uses sweeteners derived from the stevia plant, riboside and steviol glycosides, as its primary alternative to sugar in reduced-calorie products. Stevia-derived sweeteners are plant-based compounds that have been used in Japan since the 1970s and have a significantly cleaner safety record than synthetic alternatives. When Japan needs something to taste sweet without sugar, it uses something that was sweet before it was processed. 13. The assumption that approved means safe. This is the last item on this list, and it is not an ingredient. It is the idea that has kept every other ingredient on this list in your pantry. The FDA approval process for food additives is based on a standard called Generally Recognized as Safe, GRAS. A compound achieves GRAS status when experts determine that there is adequate evidence of safety under the conditions of intended use. The standard was established in 1958. Many of the compounds on this list achieved GRAS status in an era before the research that now raises questions about them existed. Once GRAS status is achieved, it is very rarely revoked. The burden of proof shifts. Rather than the manufacturer proving the compound is safe before it enters the food supply, the regulatory body must prove it is unsafe before removing it. BVO spent over 50 years under interim review. BHA remains on the list despite the National Toxicology Program's carcinogen classification. Azotocarbonamide remains permitted despite being banned in most comparable countries. Japan's system is not perfect, but it starts from a different premise. The question is not, has this been proven harmful enough to remove? The question is whether it is necessary in the first place. Most of what is on this list is not necessary. It is convenient for manufacturers. It extends shelf life. It reduces cost. It makes products look more appealing. None of those reasons are reasons to eat it. Japan decided that a long time ago. The pantry you have is the one you were given. The pantry you choose from here is yours.